Welcome to Turing Dev Talks. This is Joy, your host for the day, and I'm signing in from Nigeria. And on the panel today, we have Sanjidul joining us from Bangladesh. Sanjidul has more than 7 years of experience with backend and DevOps, and today he's a software engineer at Turing. He's an expert in Golang, PHP, Node.js, Kubernetes, among others. And today he's here to talk about Kubernetes and importance in DevOps. So let's get started. Hi, Sanjidul. First of all, thanks a lot for joining us today. How are you doing and how is work treating you?
Hey, hello, Joy. First of all, thanks for the opportunity. I'm doing well. How are you?
I'm doing great, thank you.
Currently I'm working for a good client with a good project where I can contribute and learn things which help me to grow my career.
That sounds good. Sounds like you've had quite a relaxing and fulfilling day at work. So without further ado, let's dive deep into the discussion for the day. Can you please tell our audience about DevOps and how it works?
Yeah, sure. So DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and service at high velocity, evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. So this speed enables organizations to better serve their customers and compete more effectively in the market. The DevOps workflow consists of some steps like planning. In planning, tools like Confluence, Jira have DevOps team to achieve a seamless and efficient project management cycle and ensure timely product delivery. And another phase is like build and delivery. So developer needs rapid deployment of development and testing environment and can't wait long for repairs when something goes wrong. So popular tools for this phase includes Kubernetes, Docker, Terraform, Chef, and Shabelle, and Puppet. And next phase is like testing. For these tools such as Jenkins, CI, and GitLab CI, which helps minimize the time and effort devoted to testing without compromising the code quality or user experience. And another step is like software monitoring and logging. These steps involves performance analysis and logging, raising smart alert on various issues, gathering customer feedback, and so on. So for these steps, tools are using like Prometheus, Grafana, Elastic SQL, Kestack, and Splunk, and Sumology.
That's interesting. So can we say that DevOps is an iterative process?
I think we can say that. Additionally, DevOps principle prioritize iterative processes that makes spaces for continuous testing and feedback. Again, this practice makes it possible to accelerate the development process, but it also improves the quality and security of the products.
Awesome. So today within this DevOps process, we will be primarily focusing on the build and delivery phase and one of the widely used tools to perform it. Yes, we are talking about Kubernetes. So Sanjidul, what can you tell us about Kubernetes and the role it plays within the DevOps pipeline?
Yeah, so in containerization is said to be the best way to implement DevOps. Kubernetes is an orchestrator that creates and manages your containers on cluster servers. It plays a useful role for DevOps teams that want to reduce burden of infrastructure and looking to scale, automate, and develop resiliency in their application. Some of the key aspects that highlights why Kubernetes is important for DevOps would be like no deployment downtime. So in this case, Kubernetes empowers developers to deploy new updates with no downtime due to its rolling update and automated rollback feature. Kubernetes helps to transfer traffic to other available services during deployment and update one cluster at a time. So another process would be like infrastructure and configuration as a code. Kubernetes lets developer build entire infrastructure as a code and also manage environment configuration as a code. So instead of executing a script continuously during new environment deployment, developers can simply provide the source repository to the Kubernetes. And another process is like scalability. Kubernetes offers an autonomous and continuous container-based integration ecosystem that makes application scalability and effortless process. It enables developers to scale an application up and down depending on the burden and requirements. And another phase is like cross-functional collaboration. Kubernetes provides role-based access controls to ensure that resource and configuration remains steady where environment of the smooth collaboration grows. For instance, it can restrict testers to build and pending approvals while customers review processes or deployment.
It does feel like Kubernetes performs a lot of things within the pipeline to ease the process. So can you tell us what your learning curve was when you started out with Kubernetes?
Sure. So I started using Kubernetes from very beginning, like version 1 is released. So I went through their official documentation of Kubernetes, which is resourceful and helps me to understand the whole system. For local environment, there are several tools available like Minikube, Kind. So I did the setup on my local environment, and while running, I always practice the example on the documentation. As I was the LD user of Kubernetes, that time community help like Stack Overflow was not so reachful. So I went through their code base, Kubernetes code base, which is written in Go and it is public on GitHub. So code is itself is well documented, and that helped me to learn things.
I'm sure that will help the developers who are starting out with Kubernetes to understand that it can be difficult for everyone. And on that note, let us talk about some of the benefits of Kubernetes for our developers and what makes it so popular.
Yeah, so from a broader perspective, Kubernetes popularity is due to largely to its open source nature, scalability, agility, and streaming approach. So, but there are many other benefits associated to Kubernetes that includes flexibility and portability. So, what it means, no matter the type of container runtime or the underlying infrastructure, such as on-premises service, server, private cloud, or public cloud, Kubernetes can work effectively in all scenarios. In addition, it can be deployed in a wide range of infrastructure and environment configuration, making a highly portable system. So, and another also like infrastructure abstraction. So, Kubernetes handles on its own all of the storage, compute, and networking aspects. Once installed, Kubernetes frees developers to focus on application and development without having to worry about underlying environment. And also, it includes like automatic operations. So, Kubernetes features plenty of built-in commands to address many of heavy-duty operations central to application management. It thereby empowers organizations to employ automation in many day-to-day operations.
Now, this talk of flexibility, portability, and scalability reminded me of a case study that I came across the other day. Booking.com built 500 applications on the platform in only 8 months using Kubernetes. That is simply fantastic. So, Sanjidul, now that we have touched on how Kubernetes works within DevOps and its benefits, what about the various components within Kubernetes that makes all of this possible? Can you please throw some light on them?
Yeah, sure. So in case of Kubernetes, like there is master. So what in master, it runs the API for the entire cluster. And another thing is called node. Node is the physical or virtual machine within the cluster. So, and the smallest object of the cluster is pod. So pod is the basic building block which can run a set of containers. And there is like a application container which ensures the requested number of pods running all the time. And there is object like service, which is a dynamic load balancer for a given number of pods. So that application controller allows the Kubernetes cluster to self-fill. What it means? It means it will restart containers that fail till unresponsive containers and replace and reschedule the containers if a node within the cluster goes offline. So, and if you need to roll out changes to your application or tweak the configuration, Kubernetes handles the process progressively. It will monitor the application's health to retain availability throughout the update process. Moreover, should an issue arise, the tool will roll back the changes to the work model.
Interesting. So Kubernetes have various fail-safes to make sure the process doesn't get affected. So who within these systems control these fail-safes? And doesn't that cause any security concern if it lies within one party?
The Kubernetes API is designed to be secure by default. It only responds to requests that it can properly authenticated and authorized. That said, API authentication and authorization are governed by RBAC policy, and that you can configure. Thus, the API is only secure as your RBAC policies. And also, there are basic control plane component of Kubernetes are like API server. So in API server, it exposes the Kubernetes API, and there is a etcd database which is a like consistent and highly available key value store used as a Kubernetes backing store for all the cluster data. And another control plane component is like kube scheduler, and it watches for a newly created pod with no assigned node and selects a node for them to run on. And there is also a component named kube control manager, which runs the controller processes. So there are various kube control manager like node controller. Node controller is responsible for noticing and responding when node goes down. There is controller endpoint controller, which populates the endpoint object. And there is also service account and token controller. It creates default accounts and API access token for a new namespace. And there is another control plane component is cloud controller manager. This component that embeds cloud specific logic. And in node level, there are some node components named like kubelet. So kubelet is an agent that runs on each node in the cluster. It makes sure that containers are running in a pod. There is kube proxy. Kube proxy is a network proxy that runs on each node. It allows network communication to your pod from network sessions inside or outside of your cluster. And another node component is container runtime, which is responsible for running containers. Kubernetes supports this container runtime such as container D, CRIO. So all this, all the components together create this cluster possible.
Now, Sanjidul, I think we have covered most aspects of Kubernetes, but our discussion will be incomplete without talking about how it compares with Docker. Could you tell us a bit about that?
Yeah, both Docker and Kubernetes are open cloud-native technologies, and major cloud services provide support components of both Docker and Kubernetes in their managed offering. The difference between the two is that Docker is about packaging containerized application on a single node, and Kubernetes is meant to run them across a cluster. So since these packages accomplish different things, they are often used in tandem. Of course, Docker and Kubernetes can be used independently, whereas a large enterprise may benefit from Kubernetes and can support it. Maintainers, a smaller project may benefit from just adopting a Docker. Or a company may utilize a Docker or OCI containers with another container scheduler. Similarly, Kubernetes is most commonly used with Docker containers, but it can work with other container types and runtimes.
Interesting. I'm sure this will give our developers a good idea of what to use for their own projects. And here I'd like to call upon all senior developers who are willing to work remotely with companies in the US. We have jobs in 100+ technologies, including Kubernetes. If you're confident about your skill set, head on to turing.com/jobs and apply now. It's time to wrap up our talk, Sanjidul. It has been a pleasure talking to you about DevOps and Kubernetes. But before we let you go, could you share some advice on how developers can prepare when applying to a Kubernetes profile?
Sure, absolutely. So actually my advice is like to start the Kubernetes, you can go through their official Kubernetes documentation, which is very nice and resourceful. And another option is like practice the example on your local machine, like using Minikube or kind, and try to set up a whole server, a whole ecosystem on your cluster so that it will be easy to understand and make a progress in your career.
That was quite helpful. Thanks a lot, Sanjidul. And thank you for sharing your insights about Kubernetes and DevOps. It has been quite a learning experience for me, and I hope it is the same for all of you who have tuned in for our talk. If you have any queries, feel free to drop us an email at support@turing.com. Let us know in the comment section what you'd like to learn in the next video. Give us a big fat thumbs up. And if you like this video, do not forget to subscribe to Turing.com. We will be back with many such Turing developer stories. Till then, stay safe and click on the link in the description to apply to Turing.